Hey, physics friends. I want to take you through the worksheet that I assigned to you. Sine, cosine, tangents, law of sines, law of cosines, practice number 1. I'm going to apply this algorithm to solving all 4 of these problems. A lot of people always say, Mr. Hare, I have no idea. No idea. And I get that. It's the first time you've seen a problem like this. But watch how I beat these 4 steps like a dead horse. Look for diagonal vectors. Sometimes there are diagonal, sometimes they're not. And if there's no diagonal, then you're just going to skip over, then you're going to go right to number 2. And then you go to number 3, use the Pythagorean theorem, and number 4, using inverse sine, cosine, or tangent to find your angle. So let's get started. So here's the first question up here. It says, an individual walks from home. They walk 35 miles west, turn 90 degrees to the right, walk 17 miles. They stop there and make a campfire. A, what's their displacement? B, in what direction do they have to get back if they want to walk home? And then see if their brother was at home and they wanted to walk to the person, what specific direction do they want to walk? So the thing is, with specific directions, you can't just say northwest. You got to be very specific. You got to tell me 30 degrees north of west or 60 degrees west of north. You can't just go saying general directions. So let's get started here. It's always helpful to make a picture. 35 miles west, 90 degrees to the right, so that right is this way. And then you're going to walk 17 miles. It's good to try to make this to scale as possible. At 35 is almost twice 17, so I tried to make that arrow twice as much as the 17. The better you can be to scale, the better your chances are going to be. So try to make these roughly to scale when you're making a picture. What's your displacement? Your displacement is this right here. The difference from where you started, home, to where you're at now. That's the campfire. So this one, we're going to look at those, look for diagonal vectors. There are no diagonal vectors in this one. So we're going to skip right to number 2. Add all the x components and y components. There's only one x component, 35, and there's only one y component, 17. Pretty easy to add those together. 35, 17, there's no adding whatsoever. So, next part. Use the Pythagorean theorem to find the resultant. So we're going to go 17 squared plus 35 squared equals d squared. So using the Pythagorean theorem, d equals 38.9. I'm going to save you writing it down because I'm going to assume you can all do the Pythagorean theorem. Part B, in what specific direction must they travel to get back? I'm going to go using inverse sine, cosine, or tangent. So for me to get back home, I'm right here. So getting back home is this angle for me. So I'm going to say the tangent. I'm just going to use the tangent because 17 and 35 are already there. So theta is going to be the inverse tangent of the opposite over the adjacent. So that angle right there ends up being 64.1 degrees. So that's 64.1 degrees, and this is, to me, I'm here. This direction is south to me. So this is east of south because I'm standing at the campfire. If my brother wanted to go from home, so my brother's here at home, he wants to go this angle right here. Let's call it gamma. I think that's what that is. So if this is 64.1, this is the complement. So remember how all angles in a triangle, especially this is a right triangle, have to add up to 180. So this is going to be 28.1. Oh, 25.9. 25.9 degrees. Now, for my brother, this direction is west. That's north of west. So remember, getting those directions is super important. Understanding what is north of west versus west of north, which is why I gave you all those to begin with. And here we are putting them into practice. Let's go to the next question and see how we use those exact same steps to solve a little bit more complicated of a problem. So in this problem, It says an individual walks 22 kilometers at an angle. So here's north. They walk 22 kilometers at an angle of 23 degrees. So here's 22 kilometers. And this is an angle of 23 degrees south of east. And they turn and they make a right angle. Oh boy. So this is a right angle with respect to each other. And then they walk another 16. Now, this is kind of complicated because number one, is 16, does 16 end up going above the east, or does it end up 16 when you draw it? Should 16 end below? This is where it gets a little bit tricky, but this is where that algorithm will help you. The algorithm will help you. I don't know where it ends. I'm going to guess above it, but I don't know. So here's what we're going to do. Go back to our steps. Look for diagonal vectors. So number one, there are two diagonal vectors here. The 22 is diagonal, as is the 16. Okay, so here is my first diagonal vector. We'll do this one, the 22. I'm going to bring it over here, and we're going to break it into its x. I'm going to move it down a little bit. It's x and its y components. And it's really important that because you make it your x1 pointing to the right and down, because this vector is pointing down and to the right, so you have to have one to the right and you have to have one down. So I know that this angle is 23 degrees, and I know that this is 22. So I'm going to use sine and cosine to find the x and y component of that. So I'd say 22 times the sine of 23. I'll save you a little bit of math. And that turns out to be 8.6. And then I use the cosine, 22 times the cosine of 23, and that turns out to be 20.3. So again, I used sine and cosine to find that. I'm not writing it down just for the length of this video's sake. Now, my next one is going to be this diagonal vector. I'm going to take this diagonal vector and I'm going to break it. I know that this is 16. I'm going to break it into its x and its y component. Remember, this one is going up and to the right, so I want to make sure that I have an up arrow and a to the right arrow. Here's a tricky bit. What is this angle here? Let's see if we can figure this out. A little bit of geometry for you. If I were to draw this angle right here is equal to that angle right there through what are called alternate interior angles. So this is also 23. This is 90, so this angle plus this angle plus this angle have to equal 180 degrees. So that means that this angle right here has to be equal to 67. It's the complement of 23. So this angle, 67 degrees. Now I can use the sine and the cosine to find the x and y components of that one. So I'm going to take 16 times the sine of 67, and that's going to give me the y, which is going to be 14.7. And then 16 times the cosine of 67, that's going to give me this one, which is 6.3. The x component, 6.3. Again, I just use sine and cosine to find those. I'm not putting it in there to save a little bit of time through this whole thing. Okay, so there we go. We looked for diagonal vectors, and now we replace them. So we replace. So this is the first opportunity for us. Now what we're going to do is these diagonal vectors that were in our problem, we're going to replace them with our x's and our y's. So I'm going to replace this vector with my x component and my y component. Oh boy, this is going to get really messy. Oh boy, really messy. Maybe what I should do, my x and my y, maybe, for the sake of just trying to keep things not so messy, on your 20.3, and this one was 6.1. Maybe what I'm going to do, I'm going to skip down to number 2. Add up all the x components and the y components. That's going to keep you a little bit neater. So all my x components, adding up all the x components. I have a positive 20.3 and a positive 6.3. And that's going to equal 26.6. And then I'm going to add up all the y components. I have a negative 6.1. And I've got a positive 14.7. So I know that in the y, the sum total is a positive 6. Hold on a second. Oop, I found my mistake. This is supposed to be an 8.6. So then this is a negative 8.6 here. Okay, a negative 8.6 plus 14.7. Now I'm back on track. That equals a 6.1. So in the x direction, x wins with a positive 26.6, and y wins with a positive 6.1. So I've just added all the x. Now I'm going to use the Pythagorean theorem to find the resultant. So a squared, 26.6, plus b squared, 6.1, is equal to the resultant. And the resultant, a squared plus b squared equals c squared, is 27.3. So how far away are you? 27.3. Is this miles? Kilometers? And then part B, in what specific direction must you travel to get back? So here's where you're at. You ended up here. You ended up to the right, really, really east, and then you ended up a little bit north. So you're going to have to go south and west to get home. So you want to travel back home. So let's find this angle to go back home. We'll use the inverse tangent. Right? That's step 4. Use the inverse tangent. Inverse tangent of 26.6 over 6.1. And then I get an angle of 77.1. And that's going to be this angle right here. This direction is south, so that's going to be west of south. I mean, you could also use the angle 12.9 degrees south of west. It's the exact same thing. But that's me using the... Sorry I wasn't a little bit neater and wasn't able to pictorially put all this together for you. But I was able to kind of follow the directions, you know, our little algorithm that we use. Let's do the third one. An individual walks 24 miles south, and then they walk 22 miles in a direction of 30 degrees west of south. So here's 22 miles, and this angle right here is 30 degrees west of south. How far away and what direction do you want to go if you want to go back in a straight line? So let's start again. Look for diagonal vectors and replace. So there is a diagonal vector here. It's this 22. I'm going to take this 22 and I'm going to break it into its x and its y components. This being 22, and then this angle is 30 degrees. I'm going to use sine and cosine here. So to find my x and my y components. So if I take 22 times the sine of 30, you end up with 11. Fun fact, in a 30, 60, 90 triangle, the shorter leg is always half of the hypotenuse. And then I'm going to use the cosine. I'll take 22 times the cosine of 30, and that turns out to be 19.1. This one's a little bit pictorially a little bit easier for me to replace. So I'm going to bring this one over here, 19.1, and I'm going to bring this one over here, 11, and I'm going to replace it. I'm going to get rid of my 22. And now you can see the right triangle that this forms. So I can use the Pythagorean theorem. See where I'm going? I got a big old right triangle right here. When I add up all the x and the y components to then use the Pythagorean theorem, all I'm really doing is building towards a one large triangle to do the Pythagorean theorem on. So if I add up all the x's, there is only one thing in the x direction, and that's a negative 11. I'm going to add, it's negative because it's going to the left. I'm going to add up all the y things, and they're all negative too. Negative 24 minus 19.1, and that equals 43.1. So when I'm doing my triangle, it's 43.1, and it's pointed down, and it's 19.1 pointed to the left. So using Pythagorean theorem, a squared plus b squared equals c squared, that turns out to be 44.4. 44.4 miles. And in what specific direction must they travel to get back home? So when you walk south and then you end up walking west, to get home, you're going to have to walk north and east. So let's find this angle again. Step 3, use inverse sine and cosine or tangent to figure out your angle to go home. So this angle is going to be the inverse tangent of 43.1 over 19.1. And you end up, when you do that, to be 75.7 degrees. So this is 75.7 degrees. Now, this direction is north. This direction is east. That's going to be north of east to get home. That's what you could also, again, you could also use like 14.3 degrees east of north in your answer, depending upon kind of what you found. Let's go on to our last one. An individual walks 13 kilometers north, and they turn 140 degrees to the left. And this is left. It really is going to mess you up when I send you south and then I tell you to turn to the left because it's the opposite. You'll see. 140 degrees, and I go 16 kilometers. That doesn't, see how that's not really quite to scale? Because 16 should be bigger than 13. And, just for my own humor, this angle right here is 50 degrees. Because if that's 140 from north, then that has to be 50. Okay, what's your displacement and in what specific direction? So again, we're going to go back to these ones. Look for diagonal vectors. In this case, there's only one diagonal vector, and it's the 16. We're going to bring that diagonal vector over. We're going to break it into its x and its y components. I don't know if you've noticed, but I always do x in the green and I do y in blue just to help keep my brain straight when I go to add all the like terms together. So this being 50 degrees, and this is also 16 kilometers. I'm going to use the sine and the cosine to find that. So using the sine, 16 times the sine of 50, you end up with 12.3. And 16 times the cosine of 50, you end up with 10.3. We then replace, right? So we're going to get rid of this. We're going to get rid of all this, and we're going to replace that with this vector right here and this vector right here. oops, I lost my y value, which I think is 12.3. Now, I'm going to add up all the things in the x direction. There's only one thing in the x direction, and it's negative 10.3. I'm going to add up all the things in the y direction. There are two. I have a positive 13, up 13, and then a negative 12.3. That is equal to a positive 0.7. So I actually end up replacing these right here, this 13 and this 12.3. So what in reality, when it all said and done, I end up going to the left 10.3, and I end up going north 0.7. So this is I can now find my resultant. I have added all the x's and y's, and now I'm going to use the Pythagorean theorem to find my resultant. So a squared plus b squared equals c squared, and with all of my significant figures, this ends up being 10.3 kilometers. How far away are you? 10.3 kilometers. That's kind of weird. And then what direction must you travel to get back? So here, when it's at the end, here you are, and you want to get back home. Find this angle. That angle, I'm going to use inverse sine, inverse cosine, or inverse tangent, right? The opposite over the adjacent ends up to be something like 86.1 degrees. So this is 86.1 degrees, and this direction is south to me. So that's 86.1 degrees east of south, or 3.9 south of east. So there you have it. I did all four of these questions with this algorithm. Look for the diagonal vectors. That second question wasn't really good. I wish I would have put that second question at the very end, because it's there's two diagonals. It gets tricky when you start having lots of diagonals, but look for the diagonal vectors. Break them all into their x's and y pieces, and then add them all up. And then use the Pythagorean theorem, inverse sine, inverse cosine, inverse tangent. Don't panic if you went through this and you didn't quite understand what you were doing. This is the way every chapter goes. And I hope that you're in the idea now that, like, the first time I see this stuff, super panic inducing, you have no idea what's going, but hopefully you've seen over the past 3 chapters that I can get to the place. I can get there. Fail forward. Fail early, fail often, reflect, fail forward. Good luck, kids.